Hi there. Thanks for joining us on another edition of Space Nuts, our Q&A edition. I'm Andrew Dunkley, your host. Great to have your company. And on this particular episode, we're going to be looking at black holes. Shocker. We never get black hole questions, but this one's pretty involved and lots of sort of moving parts to this question, so it might take a little bit of unraveling. We also have a question about supernova and the elements they create. Why is it so? How is it so? The Fermi paradox has been brought up, and we're going to talk time travel and magnetospheres, all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And clearing his voice to get things going with this edition is Professor Fred Watson, astronomer at large. Hello, Fred.
I should learn where the mute button is, shouldn't I, for that sort of thing, you know?
I don't even know if I've got a mute button. Hang on. I think I have. No, I haven't.
Don't press it. We might not get you back.
Yeah, I'm not game. That's the problem with digital technology.
Exactly, yes.
How you been since I saw you last 5 seconds ago?
You were very well, thank you. Still head in the clouds because of our North American tour of all the spacey things you could think of in North America.
Yes, a lot of spacey things there. And there's plenty of them all over the world these days.
That's true.
It's been a big growth industry. We've got some, yes, very true. Yeah. We've got some questions to try and answer, and I use the word try loosely. Let's get stuck into the first one. Now, this is a pretty involved question, so we'll be back in 20 minutes. But this comes from Jose.
Hello, fellow space nutters. Jose here from California in the United States. Love your guys' podcast and listen to it every day at work. I know I gotta get a life, sorry. But I was listening to an episode one day where you guys were talking about possibly, or a theory that you guys were talking about where possibly universes could exist inside black holes. And it got me thinking that, this would explain a lot of the mysteries of the universe. For example, the Big Bang. The Big Bang could have just been a supernova explosion from a star in an alternate universe, which gave existence to our universe. And I was also thinking that as a black hole, I guess, as the event horizon grows, that is actually our universe expanding. And the reason nothing can escape a black hole is because you would have to be traveling faster than light, which is not possible unless you're, the expansion of space. I guess that travels faster than the speed of light, and the material that gets sucked into a black hole, that all gets converted into dark energy, which is the energy that we can't see, or I guess the expansion of the universe that we could see. But, I was just thinking about all this. I was completely sober, mind you. I wasn't doing anything, but I know this is all speculative. I just wanted to get your guys' point of view on this. Do you guys see this as possible, impossible, feasible, or I'm just completely crazy? But I also wanted to get your guys' opinions on what you guys believe is beyond the event horizon of a black hole. Just speaking without any proof of anything, just ideas, what you guys believe. Do you guys believe, there's a white hole at the other side? Do you guys think there's nothing? Maybe you just die if you go inside a black hole. I don't know. But let me know what you guys think. I would love to hear your guys' answers. Keep up the great work, and I will be listening to you guys nonstop. Go Space Nuts.
Oh, that's lovely. I can't help but I've got to do it. The answer is no way, Jose. Couldn't help myself. Oh, dreadful. There were lots of bits and pieces in that one, Fred. I've sort of written down some notes. Big Bang, created by a supernova, which created our universe. I venture to say that's probably, I think that theory's been put forward before, but was the Big Bang caused by a supernova, which means there had to be a preceding universe before ours, I imagine. What do you think?
I'm thinking that
I can tell you're thinking.
What Jose has described sounds a lot like some of Roger Penrose's ideas, the Nobel laureate, who got his Nobel Prize for proving that black holes can exist. So he's well and truly in tune with this, but also has a theory of a kind of cyclic universe, which does involve the Big Bang effectively coming from a black hole. Now, I just looking online there to see if I could find some, pithy words from Penrose that talk about this. I do remember some years ago, I ventured into his book on this topic, the kind of multiple black hole universe theory, which is the same shape as a brick, Andrew. It's a very, very thick book indeed. And it's in two halves. The first half is all the mathematics you need to understand the second half.
Yeah.
So it left me not exactly reeling, but I'm always confronted by hard mathematics. It nearly cost me my degree back all those decades ago at university. I didn't plough into it very deeply. But Penrose is, I think what Jose is talking about are very similar to some of Penrose's ideas.
Okay.
He is, it has to be said, a maverick in his view of this kind of cosmology. His work is, I would say, viewed with certainly his work on the multiple universe and the idea that Big Bangs spawn black holes spawn Big Bangs. I have to say that is at the sort of more speculative end of the way astronomers view our understanding of the universe. We really don't have any direct evidence of there being any other universes. And in the Penrose theory, and I suspect in the ideas that Jose is putting forward there, what you end up with is multiple universes because you're inside a black hole, and black holes are 10 a penny. They're commonplace, as we know. So he asked what our view of this is, and mine is as I am on many things open-minded, but recognizing that mainstream cosmology does not see us as being within a black hole that was spawned in some sort of higher dimensional space or in some kind of multiverse scenario. Mm-hmm. So I follow this with interest. I probably should have read up a little bit more on Penrose's theory than I did. But I encourage Jose to go online and check out what Roger Penrose's model of the universe is. There will be fairly easily digestible versions of it online. Don't go and buy the brick that takes you 12 years to read because you spend the first 6 trying to understand the mathematics. I think that's
indeed
very much one for
What about the dark energy theory as to where that comes from? Black holes creating dark energy.
Yeah, well,
feeling I heard some theory or some study that came out that said there's some relationship, but I can't remember.
Yeah, we actually covered it on Space Nuts.
Yes.
Yeah. So, and once again, that is an interesting idea that I can't remember the details. It's kind of about the equation of state and things of that sort. But it was suggesting that black holes are the source of dark energy, and the mechanism I can't remember. But let me just put one other issue into the the conversation about this, because it looks as though with very recent studies of the geometry of the universe, looking back over billions of years as we can do, that maybe the dark energy is not behaving in the way that we thought it was. In fact, we covered this as well on Space Nuts, and this is to do with the equation of state. That the number is not, it was thought to be -1, which means that the dark energy is what we call the cosmological constant. It's constant throughout the history of the universe. So as space gets bigger, so does the dark energy. But that relationship between the volume of space and the amount of dark energy is constant throughout the history of the universe. It may well be that that's not true, because the new evidence seems to point to it not being. And that might once again feed back into theories like the one that Jose is talking about, where you postulate the idea of a black hole being or the universe being within a black hole. My issue with that is, where does it all come from? So if you've got stuff being sucked into a black hole from outside the universe, where's it coming from? And that naturally leads you to ideas of multiverses, which, as I said, are definitely not mainstream at the moment, although people are open to them, including, indeed, the Astronomer Royal in the UK, who I think coined the term multiverse quite some time ago.
Yeah. And his final point, what's beyond the event horizon? Could it be a white hole?
Maybe. I mean, that's what I'm just saying. In order to have something beyond, if the whole universe is within an event horizon, you've got to have something beyond it. And that leads you into multiverse theory. And white holes might, a gigantic white hole might be another kind of universe that doesn't have dark energy in it. Great thinking, Jose. I like your thinking, and very nicely put in your recording there.
Thank you, Jose. Lovely to hear from you. We've got a question from Alan. I've been reading about the gigantic supernova detected by the James Webb Space Telescope, and how it has cast doubt, amongst other things, as to whether supernovae are always or at all the creators of heavy metal elements like gold. This has revived a long-standing question I've had in relation to gold and other elements found in distinct extractable concentrations on Earth. How did such concentrations form out of the totally chaotic molecule soup of a supernova?
Nice question.
I thought it was beautifully written, to be honest.
Yeah. Just covering the first bit of that, yes, we now think that gold might be produced by neutron star collisions as well, what are called kilonovas, things that are a bit less than supernovas. So gold, but the bottom line, either way, whether it's supernovae or neutron star collisions, you've still got, exactly as Alan says, this chaotic distribution of these elements throughout space. When a supernova explodes, you've got them being created in a mishmash with lots of other elements. And so the way we find them in concentrations is, as we do on Earth, we find gold in, not just at one atom at a time, but we find it nuggets at a time sometimes, or in other forms. The mechanism to create that really involves planet formation. So you've got this cloud of dust and gas, which is much of which is enriched by elements like gold in the cloud of gas. That condenses to form a star and its planets. So the important thing here is that gravity now plays a part in it, because gravity is pulling the heavier elements together. If you've got what we call protoplanets and planetesimals, which are their precursors, planetesimals are basically baby planets in a swirling disk of dust around a star, which we call the protoplanetary disk. So those planetesimals are pulled together by gravity. And so if you've got gold, that tends to concentrate as it's pulled towards the middle. All the heavy elements are pulled to the middle. And this is a process we call differentiation. And then what happens is another planetesimal bashes into this one and it's smashed into smithereens, and then goes to form another, slightly bigger body. And eventually you've got a planet. And eventually you've got a planet with stuff in its crust that has come from these concentrations within planetesimals. So I think that's the process that Alan is looking for, why we get concentrations of these materials in the crust of a world like planet Earth.
There you go. Thank you, Alan, and fantastic question. Thanks for sending it in. This is Space Nuts, Andrew Dunkley with Professor Fred.
3, 2, 1.
Space Nuts.
Now we'll go to our next question, and this one comes from Justin.
Hey guys, it's Justin from Brisbane. I listen to your show habitually and I think you do a great job. My question's about Fermi paradox. And from what we can see, every new discovery of every planet that we find, every planet seems to be so much different from the last one, and then the next one's different, and then we're finding things that we've never seen before all the time. So isn't it becoming more and more likely the more planets we find that aren't like Earth, that Earth is totally unique in the universe? Is that becoming more and more of a possibility the more we look? Thanks, guys. Like I said, great job. Love your show.
Thank you, Justin. I love this question because it does throw up that possibility that every planet could be unique. And, and the more exoplanets we find, the more weirdness we seem to witness as a consequence of that. However, then you look at some of the moons that are within our solar system and the similarities between some of them are quite stark, like Europa and Enceladus. So it stands to reason from my perspective that there probably are other planets in the universe that are maybe not identical, but quite strikingly similar to Earth or Mars or Venus or Jupiter or you name it. I think there'd just be too many for them to all be absolutely and utterly different from one another. What do you think, Fred?
Yes. So we have discovered. Sorry, I just had a coffee delivery there.
Yeah, I saw.
We have discovered planets that are Earth-like in the sense that the size of the planet, its mass, its diameter is similar to Earth, and we might well discover more because Earth-like planets are not that easy to find. They're the smaller end of the planet range. So it was when we started discovering exoplanets at first, there were all the big ones because they're easy to find. So we may be missing a lot of Earth-like planets, but I basically do agree with Justin because we think Earth-like planets are relatively rare, but then when we look at our own planet, we see not just that it's an Earth-like planet, which it clearly is, but it's got other really interesting quirks about it, like a massive moon that may well have stabilized its rotation over very, very long periods of time. And so all of that comes in to sort of direct your thinking to the idea that maybe the sort of environment that we've had that has allowed life to flourish, and in particular to take that step from single-celled to multi-celled organisms, which we think could be a very energy hungry process and therefore very rare. When you look at that, you begin to wonder just how unique we are. And, well, you can't really qualify uniqueness, can you? But you know what I mean? We are probably unique. And it may well be that that's one of the reasons why we're not seeing alien life everywhere. Astrobiologists are fairly convinced, I think, today that, yes, you can probably get single-celled organisms forming relatively easily if you've got the right conditions. But it's much more difficult to produce multi-celled organisms, and to go on from there to vertebrates and all, primates and all the rest of it.
Giant leaps.
Giant. They're all giant leaps. And I think that in itself is the answer to the Fermi paradox, that if there are species like us elsewhere, they are so far away that you might as well forget them. We might be alone in our galaxy, for example.
Although I've been watching the 3-Body Problem series on TV, and those aliens are way too close. So, in fact, it's prompted me to buy the book, because I know it's a Chinese book that's translated to English, but makes it a bit difficult to read. But, not difficult to read, but totally different setup, because it's been Americanized for television. So you've got to get your head around that. But I'm really enjoying it. I don't know why I mentioned that. But thank you, Justin. And because it involved aliens, obviously. Let's go to our final question. We'll be real quick on this one. Hello again from James. I've got a couple of hypotheticals for Fred. Oh, thank goodness. If we could travel in time in reverse in the same fashion as going forwards, would gravity behave in the reverse like you can mathematically reverse a black hole into a white hole? And question 2, if in the future we have a strong enough power source, could we travel to a metallic body such as Psyche and put some form of electromagnetic generator at opposite ends of the body and generate an electromagnetic current through the asteroid or even a planet to generate an asteroid-planetoid magnetosphere? Thanks for entertaining my nonsense, James.
Yeah, actually, Psyche might already have a magnetosphere because it is metallic. There may be residual magnetism in there. So the answer to James's second question is probably yes, that, if you were naughty enough to think about doing that, it may already have a magnetosphere. We'll find that out when Psyche, the spacecraft, gets to Psyche, the asteroid. I can't remember when it is. I think it's a couple of years' time, if I remember rightly, something like that. It's on its way now. So you're going to look it up for me, I hope. And the first question, that's an interesting one. If you reverse...
Late July 2029.
There you go. Thank you. So 5 years' time.
Yeah.
To talk about reversing time,
yes,
we time, the arrow of time goes forward for us. And we know that the physics are symmetrical, so that you could reverse the arrow of time. And if you do that, you get white holes rather than black holes and things of that sort. But I don't know that you get negative gravity. That's a really interesting one. I'd have to think about that and maybe look up some of the equations. Negative.
I can't imagine you could reverse gravity like that. It's such a dominant force, and it seems to kind of be like we know what it is. We know what it does. It can bend things like light, but it just I can't imagine that you could equivalently flip it on its head. It just doesn't seem.
Yeah, I mean, just thinking further along from that. So we imagine that there are particles called gravitons that carry gravity. This is quantum theory that is not yet proved, but they're hypothetical particles. But they are probably, what's the name for them? Is it unipolar? It's something like that. They've only got one sign. They're only positive. It's like electrical. Right. So electrical charge, you can have positive, negative. Magnetism, you can't, which is odd. You can have north and south poles, but that's slightly different. The graviton is probably something that you can't have a negative version of. So I'm sticking my neck out here and saying that the answer to James's question is probably no.
Probably not. All right. Thank you, James. Thank you to everyone who sent in questions. Don't forget to keep them coming. You can do that via our website, spacenutspodcast.com or spacenuts.io, and just hit the Send Us Your Questions tab on the right or the AMA tab up the top, where you can send us text and audio questions. Please don't forget to tell us who you are, and where you're from. We just like to know. And I hate to do it. But we've got a dad joke from Misty, who's listening in live today. There she is now.
She must be, yeah.
How did you get your number, Fred? What did the black holes say when they collided?
Go on.
Nothing. They just waved.
Nice one. I like that. Yeah. Gravitational
clever.
wave. Very good, Mr.
Indeed.
Good one.
Yes. All right. Thank you, Fred, as always. Great to catch up again, and we will talk to you again real soon.
Sounds good. Thank you very much, Andrew. I think I'm probably missing another meeting, so I should skip off now because there's another one going on next door. We'll talk next week. We'll
For sure.
Yeah.
Awesome. See ya. Fred Watson, astronomer at large, and thanks to Hugh in the studio for being Hugh in the studio, because he's the best person in the world at being Hugh in the studio. And from me, Andrew Dunkley, thanks for your company on this episode. We'll see you next time on another edition of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.